Section 3: Atomic Theory and Atomic Mass. Chem Talk. Atomic Mass. Atoms. In Section 2, you defined the term element and explored the properties of some common elements. In this investigation, you focused on atoms. An atom is the smallest representative part of an element. The ancient Greek philosopher Aristotle did not believe in the existence of atoms. In his thinking, if atoms did exist, there would have to be empty space between them. Aristotle did not believe it was possible to have empty space. Not everyone agreed with Aristotle. Another ancient Greek named Democritus believed that matter was made up of tiny particles that could not be broken down further. He called the particles atoms, from the Greek word atomos, meaning indivisible. If you could have continued cutting the aluminum foil until it could no longer be cut by any method, you would have reached 1 atom of aluminum. A mind-expanding fact is that if you started with 27 grams of aluminum, you would find that there are 6.02 times 10 to the 23rd power atoms of aluminum. Nobody has ever counted this, nor could they. Scientists have determined this number by other means and are very confident that it is correct. Masses of element and compound in a reaction. By the turn of the 19th century, chemists were combining elements to form new substances. The new substance was called a compound, because the atoms of the elements were believed to combine to form what was called a compound atom. The chemists were also particularly interested in measuring the amounts of elements used and substances formed. Their first attempts in determining masses were wrong, possibly due to the equipment that they had available at that time. The law of definite proportions. Chemists at the beginning of the 19th century noted that 8 parts of oxygen always reacted with 1 part of hydrogen to form 9 parts of water. This observation is an example of the law of definite proportions. Joseph Proust, a French chemist, first stated this law in 1799. The law says that whenever 2 elements combine to form a compound, they do so in a definite proportion by mass. Proust based this statement on his observations. He observed that 100 grams of copper dissolved in nitric acid and precipitated by carbonates of sodium, or potassium, gave 180 grams of green carbonate. The law of definite proportions is not a direct proof of the existence of atoms. However, if you believe in the existence of atoms, it does make it easier to explain why the law of definite proportions should hold. The existence of atoms can also explain why a given mass of magnesium reacting with sufficient copper acetate in solution should always produce a specific mass of copper. John Dalton's atomic theory. John Dalton, an English scientist, developed his atomic theory in the early 1800s. His theory was based on the Greek concept of atoms and the studies of Joseph Proust. Dalton's atomic theory contained a series of postulates, or hypotheses. They were built on the data of his time and his own observations. Matter consists of small particles called atoms. All atoms of one particular element are identical and their properties are identical. Atoms are indestructible. In chemical reactions, the atoms rearrange or combine, but they are not destroyed. Atoms of different elements have different properties. When atoms of different elements combine to form compounds, they combine in a ratio of whole numbers. Dalton's postulates support the law of conservation of mass, stating that atoms cannot be destroyed, but they can be rearranged and combined with other atoms to form compounds. That means the mass of the compound must be the sum of the atoms of the compound. This law still exists today and is valid for chemical reactions, although not for nuclear reactions. Dalton's work did much to advance the belief in the existence of atoms. He hypothesized that atoms combined in the simplest possible relationship. Somewhat in error, he reported that 7 parts of oxygen by weight reacted with 1 part of hydrogen to form water. Accurate modern experiments give 8 parts to 1. More accurately, he also reported that 8 parts of oxygen reacted with 7 parts of nitrogen to form a compound he called nitrous gas. Joseph Gay-Lussac was a French chemist and physicist. In 1809, he reported that hydrogen reacting with oxygen to form water occupied twice as much volume as the oxygen. He also noted that the hydrogen reacting with nitrogen to form ammonia occupied 3 times as much volume as the nitrogen. Furthermore, he found that equal volumes of nitrogen and oxygen reacted to form nitrous gas. This gas is now known as nitric oxide or nitrogen monoxide. Gay-Lussac's data did not agree with Dalton's idea that water, ammonia, and nitrous gas are formed from 1 atom of each of the combining elements. Amito Avogadro, an Italian scientist, later resolved this disagreement. He furthered the understanding of the correct chemical formulas and atomic masses. This historical information shows how difficult it was to learn about atoms. The chemists who did this research were very intelligent people. They devoted most of their lives to trying to make sense of experiments like the one you did with magnesium and copper acetate. You can benefit from their hard work and insights. This is how knowledge evolves. That is why you are able to have the world that you live in with chemicals being used in transportation, food, medicines, clothing, and every other aspect of your life. By becoming student chemists, you are able to better understand how scientists have come to understand the world of atoms. Relative mass of atoms. Eventually, chemists determined a scale of relative masses of atoms. They did this through the organized study of chemical reactions. They measured the masses of 2 elements reacting with each other, as you did in the investigation. This allowed them to find relative masses. They could find out which elements were more massive than others, given the same number of atoms of each. Chemists were able to determine, for example, that 1 element has twice the mass of a second element. Relative mass does not tell you the exact mass measured in kilograms. It does provide a relative scale. Comparison of many reactions resulted in a scale of relative masses. Atoms of carbon were found to have a mass 12 times greater than the mass of hydrogen atoms. Oxygen atoms were found to have a mass 16 times greater than the mass of hydrogen. The units for this scale are called atomic mass units. They are defined in such a way that the mass of 1 type of carbon, carbon 12, is exactly 12 atomic mass units. The average mass of an atom of a given element in atomic mass units is known as the atomic mass. Atoms of hydrogen have an atomic mass of 1 unit. As he organized his table, Mendeleev understood the physical and chemical properties of elements. He also knew the relative mass of each element. The atomic mass is still one of the important pieces of information provided for each element on the periodic table. The table shown gives the atomic masses of the 9 elements that you observed in section 2 plus hydrogen. The elements are in alphabetical order.